Hi guys, welcome to another one of my lectures, and today I am wrapping up waves looking at the last video which deals specifically with electromagnetic waves. Now, electromagnetic waves are an example of transverse waves, and one of the special things about them is that they do not need a medium for the energy to be transmitted. That is primarily because EM waves are made up of electric and magnetic fields which oscillate perpendicular to each other, and as a result of that they can be transmitted in a vacuum, because from your knowledge of electric and magnetic fields, they do not require medium because they are considered as force fields. All right, so when we talk about the EM spectrum, we're going to first look at an example of what it is arranged, and the EM spectrum basically categorizes a series of electromagnetic waves. So there are multiple examples of waves that follow the properties that is, they are transmitted in a vacuum and they are transverse waves. Another property of electromagnetic waves is that they travel at a fixed speed in air and in a vacuum, which is 3 by 10 to the 8th, the speed of light, meters per second. Now, when we talk about them, they are arranged in the order of either increasing wavelength, decreasing frequency, or decreasing wavelength, increasing frequency. And the reason for that is because their speed is constant, so the frequency and the wavelength have an inverse relationship. Okay, so we're going to start at this end of the spectrum here, where we look at gamma rays. And in your syllabus, you are required to know the arrangement and roughly what are the range of the wavelengths and frequency values. Okay, so gamma rays go up to 10 to the minus 12. X-rays have a range of about 10 to the minus 10. UV is 10 to the minus 8. Visible light is 10 to the minus 7. And it, of course, has the range Roy G. Biv. Infrared has a range of 10 to the minus 4. Microwave has about 10 to the minus 2. Radio waves 10 squared. And, of course, TV waves, radio waves, which go up to 10 to the power of 6, 10 to the power of 8. And if we look at the top, you would see that as your wavelength gets larger and larger, your frequency gets smaller and smaller. Now, you would find that gamma rays are at the lowest end of the spectrum, and they are typically large frequency, small wavelength. And you have to understand that gamma rays basically are emanating from unstable nuclei, and they are typically used in the treatment of cancer. When you look at X-rays, X-rays as well comes from an X-ray tube, and a simple use is that medical imaging, right, where it could pass through tissue but it cannot pass through bone. UV rays are emitted from the sun, for example, as well as UV lamps, and they are used in tanning. Visible light is, of course, emitted from the sun, and it allows us to see. Infrared is emitted by very hot objects, all right, is used in thermal imaging. Microwaves are, of course, emitted by an electronic circuit, and is, of course, used as simply heating of food. Radio waves and TV waves are emitted as well by electrical circuits, and they are used as means of communication. So what I have given you is a basic synopsis of each type of wave and its use, and that you need to be familiar with. So let's just do some basic revision. So EM stands for electromagnetic wave, which goes into how these waves are generated, their components. They are examples of transverse waves. Transverse waves here. It means they do not need a medium to be transmitted. As well as they have a speed of 3 by 10 to the 8 meters per second in air as well as a vacuum. They exhibit all properties of a wave: reflection, refraction, diffraction, as well as interference, and as well they can be polarized. Right? Now, only transverse waves can be polarized, longitudinal waves cannot. So what do I mean by polarized? If you consider a glare, that is when you look at the sun, you would see light rays emitted in all different directions. And that is what a glare is. So it's very difficult to focus on an object. So when we talk about unpolarized light, we talk about light in all given directions. So the purpose of a polarizer is basically a vertical slit. And what it does is that it only allows light rays that are along the vertical plane to pass through. So when you think about a polarized sunglasses, it's basically a series of vertical slits. They call them polarizers, and they allow light along one plane, which is your vertical plane, to pass through. And that way you can be able to view objects.